Hello everyone. In the last video, we saw how to plot the simple bar charts. If you have not watched my last video, please watch it first and then come back to this one. You can find the video link in the description. In this video, we will extend our discussion on plotting simple bar charts to more advanced version of bar charts, the stacked bar charts. Now, what is a stacked bar chart? Stacked bar charts usually represent a series of bars or columns stacked on top of one another. They are widely used to effectively portray comparisons of total values across several categories. Now, for example, I can show the year-on-year product sale using simple bar chart, but if I can also add geography as a variable to this bar chart, then I can show the same information using stack bar chart, with each stack in the bar showing one particular geography. So this way I can check the sale trend across various geographies. Okay, now to show you how to plot the stack bar graph, I'm going to use the Titanic data set. The sinking of Titanic is one of the most infamous shipwrecks in history. On April 15, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with an iceberg. Unfortunately, there were not enough lifeboats for everyone on board, resulting in a death of 1,502 out of 2,224 passengers and crew members. This dataset is widely studied and used to create predictive model on likelihood of survival of passengers based on various parameters. But we will use this data to carry out exploratory data analysis in the form of stacked bar chart, and we will answer few questions such as, out of total male and female passengers on the Titanic ship, how many of them are survived? Does survival rate of passengers has any bearing on its socio-economic class? What was the survival percentage of male and female passengers? What was survival percentage of passengers based on socio-economic class? So these are some of the questions that we want to answer primarily using stacked bar charts. So let's start by loading the Tidyverse library and the Titanic dataset. The dataset is also available on the GitHub repository. So library, Tidyverse, I'm going to load the dataset and create the Titanic_TF as a data frame. So Titanic_TF, read.csv, Titanic.csv is the file name, and head Titanic TF. Fine. So let's have a look at the dataset now. Now, if you see the dataset, you can find that there is a kind of a label encoding that can be observed. So this label encoding is created to fit the data to a regression model. I think this dataset is transformed in such a way that it can fit into a regression model to generate the. So I think this data set is transformed in such a way that it can be used to create the regression models. So for example, if you see the survived variable here, survived variable, you will find two labels. Label 0, which means not survived. Label 1, which means passenger has survived. Similarly, if you go to the passenger class variable, you will also find a label encoding based on the socio-economic status of the passengers. So for example, number 3 represents the passengers traveling in third class, number 1 represents the passengers traveling in the first class. So our first task is to properly assign meaningful labels to these numeric values. So let's now start with data transformation. I'm going to first select the variables of our interest and then transform each variable into factors. And then we will rename the factor level to more meaningful definition. So let's start with the data pipeline here. I'm going to create a new data frame, Titanic underscore TF1. And I'm going to select 3 variables here: survived, passenger class, and sex. Then I'm going to use a mutate function because I want to change the. Then I'm going to create a mutate function so that I can create the factors for the first variable survived equal to factor survived. It has 2 levels, so comma levels equal to C0, 1. These 2 levels this survived variable has, and I want to label these levels. Okay, so I'm going to label level 0 as not survived and level 1 as survived. Right. So in a similar fashion, I'm going to create the factor variable for the passenger class, but it has 3 levels in this case, levels 1, 2, and 3, and I'm going to use first class for the level 1, second class label for level 2, and third class label for level 3. And in case of the third variable sex, we don't have to label it because it has already been labeled. So we'll only create the factor out of it. So sex equal to factor sex. Now let's view this data frame. Now you can see that we have transformed the data set into a much more convenient data which we can read and easily interpret. Okay, now let's generate the quick summary of each factor variables that we have created. I'm going to use a factor count function here and use this function on each variable of the data using a map method from the per package. Now this map method allows me to use this function on each variable iteratively. So dataset Titanic underscore TF1 map, and then I'm going to use factor count as the function. So as you can see, we have given the 3 summaries here. The first summary, if you see, is out of 811 passengers data that we have, 549 passengers were not survived and 342 passengers were survived. Similarly, the second summary is telling us that out of 811 passengers, how many of them were in the first class, how many of them were traveling in the second class, and how many of them were traveling in the third class. And then the third summary gives us the gender distribution. So 314 female passengers and 577 male passengers were on boarded on the Titanic ship. Right, now we are ready for the stack bar chart. Now let me again remind you that the stack bar chart usually represents a series of bars or columns stacked on top of one another. They are widely used to effectively portray comparisons of total values across several categories. We already have created the categories such as sex, passenger class based on socioeconomic status, and survival outcome. So in order to create the stack bar chart now, we will have to collate this information into a tidy data format. Remember, while plotting, while using a ggplot function, the first criteria is that the data set should be in a tidy format. So we need to convert this data into a tidy format, and then we can able to generate the stack bar chart. Now one way of generating the tidy data is using contingency table. So what is a contingency table? Contingency table is in a matrix format. That means it has rows and columns, is in a matrix format that generates multivariate frequency distribution of the variables. So you have two variables and you have the summary information of these two variables, and that's why it is called as a multivariate frequency distribution table. Now instead of explaining you what the contingency table is, let me show you how to create the contingency table by example. So let's create the contingency table for the survival outcome and passenger sex. So I'm going to create an object called contingency_gender, and I'm going to use a function called table which creates the contingency table, and in this case I'm going to subset two columns from the Titanic_df1 data frame. The first column I'm going to use is a sex column, and the second column that I'm going to use is a survived column. So table Titanic_df1 $sex, Titanic_df1 $survived, and finally view. So I'm going to create a data frame, so I'm going to use data.frame method here so that I can create a data frame from this contingency table, and now let's view the this contingency table. Now as you can see that you will get the frequency distribution between the passenger gender and survival outcome. So we have a multivariate data here. We have two variables, the sex and the passenger, the passenger sex, the gender, and the survival outcome. Similarly, let's create the second contingency table. I'm going to call it as contingency_p class. I'm going to use the same table function, but in this case I'm going to subset passenger class from the Titanic data frame, and of course the survived as a second column from the Titanic data frame. So table Titanic_df1 $passenger class, Titanic_df1 $survived. And I'm going to create a data frame out of this. So data.frame method, and finally we will view this. Now you can see that the second contingency table shows me the frequency distribution between passenger status, passenger socioeconomic status, and survival outcome. Right, now we have a neatly represented data in a tidy format. Now we are ready to generate the stack bar chart. Now remember, we want to answer the 4 questions. So now let's try to answer the first question. It goes something like this: out of total male and female passengers on the Titanic ship, how many of them were survived? Fine. Now we will use the first contingency table, con_gender, and we will use gender in this case, gender variable in this case for the x-axis, and survival frequency on the y-axis. The stack bar chart, remember, the stack bar chart shall be created using survival outcome as categorical variable. Remember, we need a categorical variable to create a stack bar chart. In this case, we will use survival outcome as a categorical variable. So now we will expect that each bar shall represent a total male and female passengers, but within that bar you will have a stacking, and that stacking shall take place based on survival outcome. So now let me create this ggplot function. So if the first layer is a data frame, in this case con_gender, then aesthetic layer. On the x-axis I'm going to use variable 1 because I want to use the passenger gender on the x-axis. On the y-axis it will be a frequency, and the categorical variable that I am going to use to create the bar chart is variable 2. So I am going to use a fill equal to variable 2. Variable 2 is the survival outcome. Right, so I finished with aesthetic layer. Now the second layer will be geom column. In this case I will be using the color equal to black. That will give me the black outline to the stack bar chart. And remember, the statistical transformation that I am going to use will be position equal to stack. Remember, position equal to stack. This statistical transformation you will have to use while creating the stack bar chart. And then I'm going to create the labels using geom text function. Label equal to frequency, size is equal to 5, horizontal just equal to 0.5, and the position, remember the position here will be position stack. Because we are using a stack bar chart, we will have to use position underscore stack method. That would automatically adjust the position of the labels as per the stacks that have been created on the bar. And if you want to use the different color, you can use the scale fill viewer function and use the different color palettes that R has. R has loads of color palettes. Out of that, I'm going to use pastel 1 color palette. So I'm going to give that as an input. So palette equal to pastel 1. Right, now let me execute this. Okay, so you can see that if I talk about the female passengers, you will see 233 female passengers were survived. And if you see the male passengers, only 109 male passengers were survived. So that answers our first question. Right? 233 female passengers were survived and 109 male passengers were survived. Now, one reason that I could find out why the survival rate of female passengers is much more higher than the male passengers is that when the Titanic was sinking, the lifeboats were used to rescue the passengers. And because the lifeboats were in the limited supply, the women and children were given the first priority while using the lifeboats. And hence, with the limited lifeboat that Titanic had, most of women and children could able to rescue themselves using those lifeboats. And unfortunately, the male passengers were given the second priority, and hence they had very few lifeboats left to use, and that eventually led to more lives being lost. So that could be one of the reasons of having a higher survival rate for the female passengers than the male passengers. Now let's try to answer the second question. The second question that we asked was, how many passengers boarded on different classes are survived? So again, we will use the contingency table. In this case, we will use the second contingency table that we have created, con_passenger class. All the other things will remain the same here, but on the x-axis, I will use passenger class as variable. On the y-axis, it will be the same frequency, and the categorical variable will be the same. The survival outcome will be the categorical variable that I will be using. So rest all things will remain the same. It's only the data that we will going to use will be con_p class. So let me first copy the entire code and change the data here, and let me execute this. Now you can see that in the first class passengers, 136 passengers were survived. 87 passengers from the second class were survived, and 119 passengers from the third class were survived. So that answers our second question. Now the survival rate for the first class passengers is highest among all. Now one reason could be that the first class passengers had immediate access to the resources such as lifeboats, and so they could be able to get the priority access, you can say, to those resources and that resources than the second or the third class passengers. However, interestingly, if you observe, the survival rate for the third class passengers is much higher than the second class passengers, and if you want to find the reason, then you may require further analysis in this. Right, now so far we have been dealing with absolute numbers. The third question is, what is the survival percentage of different passenger classes? So far we have been dealing with the absolute numbers, but if I ask you what is the percentage of male passengers, those were survived. What was the percentage of female passengers? Those were survived. So in terms of proportion, how the stack bar chart looked like. So let's now see how we can able to plot the proportionate stack bar chart. So in order to show the survival percentage of various passenger categories, we will have to use a different statistical transformation here. Now instead of position equal to stack, we will use position equal to fill as an input to the geom column function, and this position equal to fill shows the relative survival proportions for each passenger class. But remember, in this case all the bar heights will be standardized to 100% scale. So that is how the position equal to fill statistical transformation works. Now let me copy the code. The aesthetic will remain the same, but in this case the geom column, as I said, the statistical transformation will change from position equal to stack to position equal to fill. Okay, but remember, in this case you have to create a new layer here in the form of scale_y continuous function, just to make sure that the y-axis represents the percentages and not the absolute numbers. So I'm going to use this function, and I'm going to pass on labels equal to scales percent argument. Remember, this is very important layer. If you want to generate the stack bar, proportionate stack bar chart, then you would need this layer so that the y-axis scale will get transformed into a percentage scale. And finally, you can use the same color palette if you want. So if I execute this, then you can see that almost 70% of the first class passengers were survived. 50% of the second class passengers were survived, and 25% of the third class passengers were survived. So you get a very different information from the proportionate stack bar chart here. And you have a whopping more than 60% survival rate for the first class passengers. Now let's come to the last question. What is the survival percentage of male and female passengers? Now if I look at the same information, but instead of the passenger socioeconomic class, if I use the passenger gender on the x-axis, how the percentage looks like, how the survival percentage look like. So I'm going to copy the same code, but in this case I'm going to use the different data frame here, con_gender. All the rest of the things will remain the same, and if I execute this code, you can see that almost 75% of female passengers were survived and less than 25% male passengers were survived. So there is a lot of disparity in the survival rate between male passengers and female passengers. So now you can see the beauty of the stack bar chart. By using a simple stack bar chart, we could able to answer so many questions and generate so many insights from the data. Fine, let's quickly summarize now. The stack bar charts usually represent a series of bars or columns stacked on top of one another. They are widely used to show the comparisons of total values across several categories. We use statistical transformation position equal to stack for creating the stack bar chart. If you want to create a proportionate stack bar chart, the proportionate stack bar chart shows relative proportions for each category standardized to 100% scale. For proportionate stack bar chart, you can use the statistical transformation position equal to fill. And finally, we also saw the contingency table. Contingency table is in matrix format that generates a multivariate frequency distribution of the variables. Thank you very much for watching this video till end. If you are liking this content, you may like to subscribe to the channel, hit that like button as well, and don't forget to leave your comments, suggestions in the comment section. Your suggestions will help me in improving the content. Thanks for watching. I will see you soon.